So this next part is just looking at practicing some integration. So we're looking at this next one here. It looks like this one here, if we look at it, it is a product, but it's not, we can't undo product rule or anything. This is a substitution problem. Okay. So if we take a look at the inside function, okay, we're going to let the inside function be u. Okay, so let e to the x, let u equal e to the x. If I differentiate that, I get e to the x dx, which then accounts for the outside portion of that function. Okay, so this is integration by substitution. Okay, so then what I can do is I can replace that. Okay, this becomes the integral in terms of u of sine of u. Okay, and then I can replace the ex dx with du. So this integrates with respect to u. It's just a straightforward integral. It's going to be negative cosine of u plus c. We want to get rid of that u. We replace the u with the equivalent e to the x that we have here. Plus c. So there's my integral. We'll call big F is equal to negative cosine. Okay, this one here, same thing. We're just integrating this. This is an embedded function. We want to look for an inside function whose derivative is equal to the outside. In this case here, my du is going to be equal to 1 over x dx. Yeah, that derivative takes care of the remaining outside. So when I do my substitution, I end up with sine of u. Okay, so there's my u. I can replace the dx over x with a du expression. There it is. It's my integral in terms of u. We can anti-differentiate this to cos u plus c. Okay, and then again, this time we're replacing the u with the equivalent log x. And there's our antiderivative function. This one here, looking at this, we have to use the fundamental theorem of calculus in that we know we certainly cannot anti-differentiate this. We have multiple layers of embedded, which we can't undo with substitution. Yeah, it's way too complex. But we are taking the derivative of this integral. Well, if that's the case, then we can integrate this, and this, I think, is a typo. This should be a different variable than the x. Okay, it's a bit of a formality, but we shouldn't really have the same variable here, the variable of differentiation with this variable here. So if we anti-differentiate this and differentiate it, we should end up back to the same expression. So that's what it's going to look like. Okay, so we're going to end up with 1 over x squared and embedded in the log. Okay, so the derivative of the antiderivative undoes itself. This is a fundamental theorem of calculus. We can kind of show this in this way. We can say that big F, okay, we want to take the derivative. When we anti-differentiate this, we're going to get big F at x minus big F at a. The derivative of this is going to be f of x minus 0. So we end up with the original starting function f of x. Okay, so that would what we would have started off with inside this expression. Okay, so there's my f expression. Okay, so again, we can, these ones, if you remember the fundamental theorem of calculus, is fairly straightforward. We basically, the derivative and antiderivative undo each other.